Hey guys, so today we're going to be talking about trig graphs again, but we're going to be talking in a little bit more general terms to start with. So I'm going to be looking at all of the different shifts and stretches that I could do to a trig graph. So right here in purple, we have sort of the general equation of a trig graph. Y equals A times sine of B times x minus h plus k. Now this could also be a cosine graph. It would just change the original shape of the graph, like you guys have been seeing in class. So this holds for cosine also. So A is going to affect the amplitude, and I bet you guys started to notice that today. And be careful, it's the absolute value of A that's the amplitude. So if I were to look at this example down here, negative is going to flip my graph, but 3 is actually going to be my amplitude. So this negative sign is going to reflect. The 3 is going to give me my amplitude, so my amplitude is going to be 3 on this curve. And then this B, whatever is in front of the x basically, we saw today in class affects the period. Okay? So for instance, if I have 1/4 in front of the x, then I'm going around my unit circle a quarter of the speed that I would normally travel. And going around the circle a quarter of the speed is going to mean that it's going to take 4 times as long to get my sine curve. Okay, so the graph itself will take us 4 times as long to happen. So this affects my period. It would normally be 2 pi, but it's going to be 4 times as long. So I would do 2 pi over 1/4 to find this algebraically. Dividing fractions is easy as pi, flip the bottom and multiply. 2 pi times 4 gives me 8 pi. So instead of being 2 pi, my period is now going to be 8 pi. And then here, if you have an h inside of the parentheses, like x minus 2 or x minus 5, we're going to look at one like that later, where we have something here. That's going to shift our graph left or right, just like anything in the parentheses always does. And if we have a number outside, like a k, then it's going to shift our graph up or down. So for instance, here we have this 2. This 2 is going to shift it up 2. Now, in terms of what happens first, second, third, or fourth, the first thing to consider is your parent function. So I'm going to underline sine and put that in. I'm going to dot it in. Now, considering that I'm going to have to go out to 8 pi, I'm going to think a little ahead. I know sine has a period of 2 pi, but I want to eventually go all the way out to 8 pi. So I counted out a multiple of 8 here. I counted out 16 squares because 8 goes into 16. I'm going to make this my 8 pi. That means that each one of these little guys is a half pi for me right now. So if I go 1, 2, 3, 4, 4 half pies, or 4 pi over 2s, is the same as 2 pi. And then 1, 2, 3, 4 would give me 4 pi. 1, 2, 3, 4 would give me 6 pi, and 4 more would give me 8 pi. Now the reason I care about that is because I want to show a dotted line of the original function. Sine starts, let's think unit circle here. So I have my first point, 0, 1. Sine starts at 0 because sine is the y-coordinate. So let's see, I start at 0, and then it goes up to 1 at pi over 2, and then back down to 0, down to negative 1, and back up to 2 pi. So this is pi, and this is 3 pi over 2. Okay. So my original sine curve is this little bitty teeny guy. Okay. There's my original sine curve. And then when I decide what happens next, I go order of operations. So if I'm thinking PEMDAS, right, parentheses goes first, which means the first thing that you would want to show if you're showing all of these shifts individually is this 1/4 change. You'd want to show the change in the period because that's inside the parentheses. So that means that I'm following the normal sine curve, this guy, but now I'm stretching it out. So I still start at 0, and then I'm still ending at 0, and my middle point is still at 0. And then between my 2 zeros, I achieve 1. So between these 2 zeros, I achieve a 1. And between these 2 zeros, I achieve negative 1. So here's the next step of my sine curve. Oh, negative 1 is right there, sorry. Okay, so then now I look and I say, okay, I did parentheses. There aren't any exponents in this situation, so now multiplication. So that means that I'm doing this multiplication by -3. So when I do this, I'm now changing the green graph because each change affects the ones that come after it. So if I multiply by -3, 0 times -3 stays 0, so that one stays put. 1 times -3 is going to be, so this is the point up 1. If I multiply 1 times -3, I'm going to get -3. So let's see, I'm going to go down 1, 2, 3. Here's -3. So that reflects down here. 0 stays 0. -1 times -3 is +3. So I'm going to count 1, 2, and put the graph literally at 3. And then 0 times 0 is 0. Or 0 times -3 is 0. So now I'm going to get this dotted line. Okay, so that's my sine curve. And let's see. So first I did the period, and then second I did the reflection and the multiply by 3. Next in PEMDAS comes division, there isn't any, and then addition and subtraction. So now I'm going to move everything up 2 to draw my final curve. So I take each one of my points that's off the blue graph, and I go up 2. And then this guy goes up 2, this guy goes up 2, this guy goes up 2, and we're almost running out of room there, and this guy goes up 2. It's sometimes helpful because you're going to start getting a lot of lines. This is already looking kind of messy just a little bit. To move your midline of your graph, the center of the wave, up 2 also. So my center of my wave is going to be here. And then from there, you can very carefully draw in your sine curve. Okay, making sure to put arrows on the ends. So from this teeny tiny little orange original curve, that was the original sine graph, we now have this big, long, stretched out, shifted up sine curve. Okay. I would recommend using colored pencils when they get more complicated in class tomorrow, or colored pens, but probably pencils because you can erase them. I would also recommend showing each individual shift until you get the hang of it. So if you've never taken trig before, absolutely show the shifts as you're going. If you have taken trig, I'll let you feel it out. I do want to see at least the original curve and the final curve. That's like the bare minimum. All right, the next example, we've got a shift, and this time it's simpler. It's just a phase shift. This is going to shift it the opposite of what you would think, so it would shift it right pi over 3. Now in this case, I do want to see the original curve, so I do want to see you go out to 2 pi. So let's see, I'm going to go, so let's see, I'm going to make my things go by pi over 2's again, so here's 2 pi, and then half of that is pi, half of that is pi over 2, oh I guess I'm counting by pi over 4's this time, and this is 3 pi over 2, right? And it's a cosine curve now, so I think up to my unit circle, cosine starts at 1. I'm going to make that 1, I guess. And then I better make that -1. And then it goes down to 0, down to -1, and back up. So here's my original curve. And now if I'm shifting everything right pi over 3, the easiest way that I know how to do this is to think about how much distance pi over 3 is. So if I come down here, I know pi over 3 is less than pi over 2. So that amount of distance right here, if you guys can see it, is about pi over 3 approximately. And so I want to take all of my points over this amount of space. So I'm going to go over, this guy goes over, this guy goes over about the same amount of space, so does this guy, and this guy, and this guy. And I get my shifted cosine curve, okay? Just one period of the shifted cosine curve. Oh, by the way, the period here is 2 pi since we didn't have anything in front of the x, and the amplitude is 1 because from the center of the wave to the top is 1 unit, even though I made it look like 2 because I used 2 boxes for 1 unit. All right, last but not least, we're going to throw in a really tricky one here. So this 3/4 is going to affect our amplitude. Our amplitude is going to be 3/4. This 2 in front of the x is going to affect our period. So we'll do 2 pi over that number. 2 pi over 2 is pi. So we should expect the period of our final graph to be pi. And then this guy, this is really, really sneaky. In the general form, notice the b is outside the parentheses. And right now, this 2 is inside the parentheses. This is super, super sneaky. What we need to do is take this 2 outside of the parentheses and put it in front of the parentheses right here by factoring. So if I'm going to factor a 2 out, I'm technically dividing both of these things by 2 because factoring is the same as dividing. So 2x divided by 2 is x. And 2/3 divided by 2 is 1/3. Or 1 pi over 3. You don't really need the 1 there though, right? And you can double check because 2 times x is 2x. 2 times pi over 3 is 2 pi over 3. So really our phase shift here is pi over 3 to the left, going the opposite direction since we're in the parentheses. Okay. So graphing this. First, just always graph the original. You're just going to save yourself so much pain and heartache and so many points if you just graph the original graph. So I've got cosine graph. I'm going to choose how far to make 2 pi go out. So let's see, 1, 2, 3, 4. I'm going to go out 8 of these guys. Half of that is pi. Pi over 2, 3 pi over 2, right? And then I know cosine starts at 1 and then goes down to 0, -1, 3 pi over 2, and 2 pi. So, boom, just a little cosine graph, and I'm already getting partial credit for showing some work, showing the original graph, okay? Now, we're going to affect the amplitude and the period, and I'm going to do these two together because I bet you guys are starting to catch on, and then I'll do the phase shift last. So if I do the amplitude and the period together, let's see, my amplitude now is going to be 3/4, so it's going to go up to 3/4 and down to -3/4, right? And the period now is only going to pi, so I'm cutting each one of these guys in half. So it's still a cosine curve. It still starts at its high point, goes to 0, down to its low point, back up to 0, back up to its high point. So it got shorter and it got more narrow, right? The frequency changed. And now a shift of pi over 3 to the left, again, you kind of need to pay attention to how much pi over 3 is. I know pi over 3 is less than pi over 2, so it's about that much. And I'm going about this much to the left each time. So this point's going to go just a little bit more. It's like a 1.5 almost. So this point's going to go about a 1.5. This one's going to go over about 1.5, not quite, about 1.5, 1.5, and about 1.5. And if it helps, draw little arrows and make sure the arrows are all about the same length. And then you're going to connect your dots. And there's your funky shifted cosine curve. Alright guys, that's it for notes. We are going to be doing a bunch of this tomorrow in class, so maybe rewatch it if anything was confusing or if this is your first go around on this, and I will see you tomorrow. Thanks!